We are going to be looking at how to determine the vertex form from a graph or information. In the previous lesson, we looked at how to graph from vertex form. So in this lesson, we are going to be determining vertex form from the graph. So it's the exact opposite. In order to determine the vertex form of a specific quadratic function, which is y is equal to a times x minus h squared plus k, we must have specific values for a. So you have to know what the coefficient is, which I'm highlighting in pink here, and also specific values for h and k, which I'm also highlighting in pink. To do this, you must know, first of all, the location of the vertex. This helps determine the values for h and k, and then the location of some other point, and this is going to help to determine the value for a. And as I have in green here, that other point can often be the y-intercept, but not always the y-intercept. So let's go ahead and look at this first question, which says, from the graph or information, determine the vertex form of each quadratic function. So from this particular vertex, we know that it's going to be the opposite of negative 3 in the brackets, which is plus 3, and the same as 5 on the outside, or the constant term on the end. So from the vertex, we know this much. From the vertex, we know that the function is y is equal to a times x plus 3, that's the opposite of negative 3, squared plus 5. Okay? Now to determine the value of a, we know that a is negative, but we want to know which value. We know that it's negative, but we'd like to know if it's negative a half, negative 1, negative 2, negative a million. So let's go ahead and see if we can figure out what it is. In order to do that, we're going to substitute some other point. In this case, the other point that we know is 0 and negative 4. We are going to substitute 0 and negative 4 to determine a. So I'm going to replace x with 0 and y with negative 4. So it's going to be y, which is negative 4, is equal to a times x, which is 0, plus 3 squared plus 5. And we're going to solve for a. So we have negative 4 is equal to a. 0 plus 3 is 3. Now we have negative 4 is equal to, and 3 squared is 9. So it's going to be 9a plus 5. And now if I subtract, I'm just going to do the opposite operations, inverse operations to solve for a. The opposite of adding 5 is subtracting 5. So now we have negative 9 is equal to 9a. The opposite of multiplying is dividing, so we'd have a is equal to negative 9 over 9, which is equivalent to negative 1. So there's your value for a. So your final vertex form function is y is equal to a, which is negative 1, times x plus 3 squared, because that is the opposite of the x-coordinate of the vertex, plus 5. There's the specific vertex form of that quadratic function. Okay. The next question does not give us a graph, but it's an interesting question. It says we have zeros of negative 5 and 1. What that means is those are our x-intercepts. So that's negative 5 and 1, so negative 5, 0, and 1, 0. And it says we have a maximum value of 6. So what that means is that it touches, or the top value, the vertex touches positive 6. So the vertex falls somewhere along this line. And by symmetry, what we know is it falls directly between 1 and negative 5, which is at, so this is our axis of symmetry, that would be at x is equal to negative 2. So given the zeros and given symmetry and given the maximum value, we know that your vertex is here based on those facts. So the vertex would be at negative 2 and 6. So at this point we have enough information from the graph to determine the vertex form. From the vertex, we know, the following, that the vertex form is y is equal to a. We don't know the coefficient, but we know that it's negative, times x plus 2 squared, because that's the opposite of negative 2. And in this case, plus 6, because that's the y-coordinate of the vertex. Now, we don't know the y-intercept, but we do know some other point. You can choose either of these points that I'm highlighting in blue to substitute into this function in order to solve for a. I'm going to substitute the point 1, 0. So I'm going to substitute 1, 0 to determine the value of the coefficient a. So y, which in this case is 0, is equal to a times x, which is 1, plus 2 squared plus 6. So 0 is equal to a times 3 squared plus 6. 3 squared is 9, so it's going to be 9a as your coefficient plus 6. And now we're going to solve for a. So the opposite of adding 6 is subtracting. So it's negative 6 is equal to 9a. The opposite of multiplying by 9 is dividing. So we'd have a is equal to negative 6 over 9, which is the same if we reduce that to negative 2/3. So our final vertex form would be a combination of all the things that we know. So y is equal to a, which we know is negative 2/3, times x plus 2 squared, because we know the x coordinate of the vertex is negative 2, plus 6, because we know the y coordinate of the vertex is positive 6. Okay? If you're in my class, you would do this question and get me to look at it.